Hi, this is Mr. V. This is the second video you guys will be watching this year. It is on order of operations. Order of operations are actually pretty key. We're going to be using it throughout the whole year. Graphing, exponentials, percents. It is something that you have to know to do almost any problem correctly. So we're gonna try and develop a really good foundation on it this next week and a half of work. Order of operations, you probably heard of PEMDAS, which is parentheses, please excuse my dear Aunt Sally, parentheses, exponents, multiplying, dividing, adding, subtracting. We are going to use instead grouping symbols instead of parentheses, so we say GEMDAS because it's grouping symbols is more of a general phrase that we'll talk more about, like what they are and whatnot. So we have a vocabulary list. Most of it's pretty self-explanatory. We are mainly going to focus on expressions and grouping symbols. Exponents, multiplying, dividing, adding, and subtracting. That should all be pretty clear. I do use the little phrase, "go to eat my dad's applesauce," to help me remember it. So, here we go. And we got a lot of vocabulary to do the first part of this video. An expression, it's a statement made using the language of mathematics. They can include just numbers, variables, operations, and or a combination of these things. So it might just be the number 5, it might be x, it might be 5 and x, so 5x. An operation is multiplying, adding, subtracting, dividing. It is not an equal sign or an inequality sign. That makes it an equation or an inequality. No equal sign, no inequality symbol. Those things make it an equation. So an expression has none of those things, but it can have adding, subtracting, dividing. So, by the way, when the videos like this, it's a good time to pause and take your notes. Because I'm just going to keep on going. Keep on trucking. Grouping symbols. Sorry, still getting used to the setup I have here at my place. I'm used to a different setup. So, grouping symbols. These are used to show the piece of the expression, I know it's hard to read, of the expression that take priority when simplifying. Again, these are used to show the piece of the expression that take priority when simplifying. So it's like an idea about it, and this is really how I see it. Like, I really see it. It's like having a mini expression, a little tiny expression, within the main expression. That's what grouping symbols do in my mind. Like, you have to take care of that little tiny part before you can do the big part. And that's something that takes some time to get used to. Types of grouping symbols. So we've got quite a few types. You're probably used to a couple of them, just fine. That's the whole point of learning. We're just gonna get used to more and more different things. Parentheses, you've used those before. Brackets, you use a bracket if you have a parenthesis inside of a parenthesis. You would use a bracket instead. Braces, same thing. If you have 3 sets of parentheses, you would use braces eventually. And we'll be going over this the next few weeks. Absolute value is going to be in tomorrow's video, and we'll talk about what that is tomorrow. And then fancy fractions, and I call it a fancy fraction because you add on top before you divide, and I'm going to talk about that in our third example today. Some examples of expressions, I've written down some of them at the bottom. It could just be the number 5 or -3. It could be 4x, 3x squared, 5 plus 7x, 8x squared plus 9x minus 16, the square root of 3x squared, 14 minus 19. And you'll notice lots of adding and subtracting, there's no equal sign, because that would make it an equation, not an expression. So that's always the main thing to keep an eye out for. Alright, so that is our first little thing. Yes, my phone is starting to go off, but I would rather get this video done instead of answering it, so I'm going to ignore it. Because you guys are just that much more important to me. Okay, so this is me moving on. This is example number 1 that we're going to be doing today. We're going to be simplifying an expression. The angle is up so I can get a little bit better writing platform. So simplify means you've got some expression and they just want you to turn it into a simpler looking number. Let's see. So we've got 6. By the way, you'll notice erasings. I have done this video twice already and I'm restarting. So, sorry. 6 times the sum of 23 plus 23 and 71 minus 426. So there's a lot going on here. The first thing I'm always going to insist on is you always rewrite 23 plus 71 minus 426. And I want you also, so this is something you need to do, so it better be in your notes when I check them tomorrow. I want to see you writing down exactly what you're doing. I'm rewriting. I did the rewrite. Next, well, do I multiply first? Because there's a multiply symbol. They're not going to put it. You have to know that. Do I add or do I subtract first? Well, we've got a grouping symbol. So because we have a grouping symbol, I'm going to put grouping. And we're going to add inside of there. So 6 times 23 plus 71 is 94 minus 426. So now the question is, what am I going to do now? Do I multiply first or subtract? Going back to order of operations, we should be multiplying first. So 6 times 94. Now I don't want to like multiply it out right here. I don't have much space, so I'm going to show my work over here like above it, because I still want to see your work, but I don't want to see it in the main area of what's going on. Do it on the side, do it on our piece of paper, but just don't do it on the main area. 6 times 4 is 24. 6 times 9 is 54 plus 2 is 56. So we have 564 minus 426, right? Now we're going to subtract, and if you need to get some more space for it, that's no problem either. Just do it on the side. Don't do it right here. Do it somewhere else. We've got to borrow, carry to 1. 14 minus 6 is 8. 5 minus 2 is 3. 5 minus 4 is 1. So we have 138. And I'm going to bring this part down to show that this is equal. Minus 426. And notice, by the way, I use the balance line to line up my equals so I can make this look nice and neat. Okay? And that's the first example. Oh, I forgot to write down that I subtracted at the very end. Subtract. Okay, so I want you to be using the balance line. I want you to write down exactly what you're doing, and I want to see your work. Just don't do it in the main area. Do it on the side. Okay? All right, example number 2. Evaluate is what you'll mainly see and what you'll be mainly tested on. It's an expression with variables, but I tell you what the variable equals. So like on here, 18a divided by 4b, I'm telling you what a equals and what b equals. So you have to plug it in and then evaluate, which is basically a fancy way of simplifying. I'm going to show 2 ways of doing this problem, because there is a really neat way of doing this, and we'll get to that after I do the main way. I'm going to use GEMDAS, so order of operations first, and I want you to write down both ways. I have 18a over 4b. I am rewriting. Draw my balance line. Okay, now I'm going to substitute in. I find that when I know I'm replacing stuff, I'm going to put parentheses, 4 and then parenthesis, but first, before I just start putting stuff in. Like whenever you plug in a number, or substitute, so we're substituting. Whenever you substitute a number in, you always put parentheses, period. So A is equal to 8, and B is equal to, you can't see that up there, B is equal to 18. Okay, so I'm going to put that right there. You have no idea what that's going on right there, so I don't really need to cover it. Okay, so I'm going to plug in that 18. 18 times 8, I'm going to do that on the side right here. 4 carry to 6. 8 times 1 is 8, plus 6 is 14. So we have 144, which is also the square of 12. And then I have 4 times 18. So again, 4 and 8 makes 32. 7, so this is 72. So what have we done so far? We multiplied. So order of operations, we're multiplying. And now we're going to divide on here. We're going to divide. Sorry about the screen blacking out. We're going to divide. So here we go. 144 divided by 72 is actually just equal to 2. Okay? Okay? So 18 over A divided by 4AB is equal to 2 when you have these values for A and B. Now if I change A and B, would my answer change? So I want you to think about that tonight because that's going to be on the warm-up tomorrow. Okay? So we have number 2. Simplifying fractions. And this is the second way. And I do want them side by side. I'm going to rewrite. And I'm going to show you when I'm going to substitute just like before. And I'm going to notice what's on top and bottom. Well, hopefully you're noticing 18 divided by, I have 18 over 18. And if you think like a fraction, I can just simplify 18 divided by 18. I know this is just equal to 1. I can just turn that into 1, and what's left on top? 8. And what's left on the bottom? 4. So I'm just simplifying a fraction. What's 8 divided by 4? Instead of 144 divided by 72, what's 8 divided by 4? Well, that's equal to 2. And we're done. So 2 different ways of doing it. It's up to you what you want to do. And I did divide at the very end. So, again, up to you. Alright, we have 2 more examples to do. So, here we go. Something I'm noticing is I ran out of room the last time I made this video. That's why I redid this. So I'm gonna bring it up here and raise it up a little bit. A plus 17 over A plus 17A. So I'm gonna use order of operations, and I'm gonna have A plus 17 divided by A is equal to, I'm gonna rewrite plus 17 is equal to, well, I'm just going to rewrite it. Okay. I'm going to substitute in 17, so I'm going to show that with parentheses. Right? So what I have right here is a fancy fraction. And the thing about this fraction is I could take this and I could technically rewrite it that this plus 17 divided by 17 is the same as if I had 17 plus 17 parentheses divided by 17. In which case you would know from right here, you know you're supposed to add first and then divide because of the grouping symbol. So that's why I say fancy fractions, because technically it looks like this. So that's why we always add, when it looks like this, when you have 2 numbers on top of a fraction, you add those numbers together. So you got 34 over 17 plus 17. 34 divided by 17 is 2 plus 17. And that is equal to 19. And that's my answer. Okay? So a little bit of a tricky one. That could be really hard to do. So we'll be doing some more examples of that in the next few days. Example number 4. This is our last example of this video. It's a true or false question, and I want you to explain your choice. 4x minus 19 is equal to 5 when x equals 6. So I'm asking you, when x equals 6, is that the answer to the equation? The way we're going to do this is I'm going to start the balance line. And something to point out right now is this is checking our equation. We're going to be doing this all year because this is how you make sure that you got an equation right. So you're going to be doing this all year for every single equation you do in my class, including on tests. You have to know how to do this. I'm going to substitute. So I'm substituting in. For x, I'm plugging in the number 6. Do I multiply or subtract first? I multiply first, right? Order of operations. 24 minus 19 is equal to 5. I'm going to subtract. I know I put sub instead of substitute. Well, 24 minus 19 is equal to 5, and 5 is equal to 5. So, this is true. The end. Okay? And it's true because, well, we plugged it in. In 6 for x. Alright? And we are going to be doing this right here. This is going to be all year. So it's really major. Alright, so that's our first video on order of operations. We will be doing another video tomorrow night. It's part 2. If you go looking for it online and you really want to watch it tonight, you can. But you don't have to. It's going to be tomorrow night's assigned work. So, see you tomorrow. Have a good day.